I'm Sean Sullivan, and this is my video on reading graphs. So to start off reading graphs, you should begin by knowing how to find x and to find y. So in order to find x, finding x is very easy when you know your slope and x coordinate. If in a situation where you wouldn't have your slope, to find your slope, use formula m equals y2 minus y1 over x2 minus x1. That makes sense? So now let's discuss how to find y. So find y, look at your y-axis. And then find out where y and x meet. And you can use the same thing for x. Find out where y and x meet. So if you look at this, here's a little example. Let's say we had a graph. Oops, that's a little bit crooked. Got my eraser. Say we had a graph that went to 2, 4, 6, 8, -2, -4, -6, -8, 2, 4, 6, 8, -2, -4, -6, -8. So let's say we had a point that met at 6 and -6. So you could determine what your x and y is by finding that, drawing that out to there, and drawing that out to there. And then everyone knows this is your x and this is your y-axis. So does that kind of make sense? And then you could see the slope. So the slope is up 1 to the left 1. All right. So when let's say f to x is greater than 0, it is increasing. So when f of x is greater than 0, that means it's increasing. And if f of x is less than 0, that means it is decreasing. Kind of makes sense? So, because if it's over 0, then that means it's increasing. Under 0, that means it's decreasing. So, and then here's another 2 good points of information. If f of x is above the x-axis, it's positive. If f of x is above the x-axis, that means it's positive. But if it's below x-axis, that means it is, guess what? Negative. Does that sort of make sense? If f of x is below the x-axis, that means it's negative. Now I'll show you guys what domain and range is. So, the domain really just means the set of all x values of the relation. The range the set of all, guess what? Y values of the relation. Does that make sense? So the domain's the set of all the x values, the range is set of all the y values. That kind of makes sense? So now I'll show you guys what relative relative maximum and what absolute minimum means. So if, let's say f of x has a relative maximum. Let's say it was just at, it doesn't even matter. Let's just say it was at xc. That's an example I've heard. Let's say it just had a relative maximum at xc, just for example. Then that means f of x is less than or equal to f of c. That's if it just has at a random spot of xc, then that means it has a relative maximum at xc. Sort of makes, at fc. That sort of makes sense. Now, let's say f of x. Now let's cover f of x. Let's cover absolute minimum mean. What absolute minimum means. So if f of x has absolute minimum, at, let's use the example of x equals c again. At x equals c, then that means, so if it has an absolute minimum at x equals c, then that would mean f of x is greater than or equal to f of c. So that's sort of what absolute minimum and relative maximum. Relative maximum means if it has a relative maximum at right here at this, if x equals that and it's a relative maximum, that means that f of c is greater than or equal to f of x. And then if it's an absolute minimum, then f of x is greater than or equal to f of c. Does that make sense? Now, I'll show you guys now limit notation. So, for example, when limit notation goes to the left, talk about when limit notation goes to the left. Or how about we start with when it goes to the right? So when it goes to the right, that means fx equals fx to infinity, or fx approaches infinity. So it's going to infinity, approaches. So now let's talk about when, so that means, so when it's going to right on a graph, when the limit notation is going to the right of a graph, that means it's approaching infinity. Understand? So what about limit notation goes to the left? I think you guys got this one. So if you look at this and it goes to the left, then that kind of means f of x equals f of x approaching or going to negative infinity, because it's going to the left. Like look at this, like look at a graph. It's going to the left, of course it's approaching negative infinity. It's going to the right, of course it's approaching infinity, because this goes on till infinity, and this goes on till negative infinity. If this go, boop, that's towards negative infinity. That go like that, boop, that's towards infinity. You guys understand? You guys understand that? So if it's to go this way, of course it's going towards infinity, because that's infinity. If it goes this way, of course it's going towards negative infinity. Either or. Kind of understand? So that is all I was going to cover in this video